We're going to talk a little bit about slope fields today as they apply to differential equations. Now, if this is the first time you're seeing my face, hi, my name's Dr. Marissa May. I am on a mission to help students feel confident in their math classroom. So, this video and these examples are just one of the tools and resources that I have available. If you're needing some help with any other math classes or possibly needing some other type of resource, feel free to leave me a comment below or in my description, there are my social media. You can send me a DM through one of those, and I'll be happy to help you in any way that I can. Before we get started, though, don't forget to hit the like and subscribe button. That way, you get a notification every time a new video is posted. So let's jump right in. Now, a slope field is simply a picture, a representation of all the solutions that could be possible for a differential equation. Now, you may be thinking to yourself, how can there be all of these different solutions to a differential equation? And I'm so glad you've asked. So let's take a look specifically at dy dx equals x plus 3. Now, we will, if you've seen my previous video, you know I separate the variables by multiplying both sides by the dx. And now I'm ready to integrate both sides. So when I integrate both sides, easily I get the y on this side. The antiderivative of x would be 1/2 x squared. And the antiderivative of 3 would be 3x. And then always remember we have that constant of integration. Now, that constant of integration gives us an infinite number of solutions to this differential equation, because really we could have this curve that satisfies this differential equation. And now that plus c is just shifting it up or down. Okay. So there's four things you need to be able to do if you're taking the AP exam with regard to slope fields. So the first thing is you need to be able to sketch a slope field when given the differential equation. So that's item number one, and we'll do some of that. Okay, item number two, if you're given a slope field, then you need to be able to draw a particular solution. Now, obviously, because of the way the AP exam is set up, that would be a free response question, and we have seen that before. Okay, number three, match a slope field to a given differential equation. And you can see that would probably be like a multiple choice question. And number four, match a slope field to a solution. Okay, so those are your four things you want to focus on just to get ready for the AP exam. So let's take a look at number one. If we need to sketch a slope field for a differential equation. Now, the thing to remember with a slope field is you've got an equation for your differential. I would suggest probably, since this differential equation only depends on x, I'm only going to have two columns in my chart, because I'll show you how they apply for multiple points. So let's do real easy. Let's do when x is 0. Okay. When x is 0, dy dx would be 0 minus 1, which is -1. That means for every point on this graph, when x is 0, the slope is going to be -1. So I'm just going to start here at this point, and I need a slope of -1. Now, -1 would be down 1, right 1. So this point here, while I'm not using it, I'm going to use it to line up my straight edge, because I'm just going to draw a little segment there. I'm going to do this point next because its value, it has x is 0. Okay, and down 1, right 1, again, slope of -1. I'm going to use this point to line up my straight edge. And again, I'm just drawing a little segment. Okay, now watch what happens when I get here. I can't go down 1, right 1. So this time I go up 1, left 1. So this is my point I'm going to line up my straight edge with and draw my little segment. Okay. And I'll go ahead and do these up here where x is 0, again, using the other point to line up my straight edge. All right. So there you go. That takes care of all of the points when x is 0. Let's do when x is 1. Now, when x is 1, the slope is 0. So that means we need to be horizontal. Okay, so here's a point when x is 1. I'm going to line up for a horizontal line and draw my little segment. And again, you get the idea. Right? And then you can do when x is 2, and my slope would be 1. Okay, and so use your other points to line up here. Oops, sorry, I drew the wrong. This one should be here. And then, so for this one's going to be hard because I won't have another point to line up with, right? Okay, do when x is -1, your slope would be -2. So from here, you want to be down to right 1. So you're lining up with this point, you're lining your straight edge up with this point over here. There we go. And here. And here. You get the idea, right? And when you get to where you don't have one to line up down and right, now you go up and left. So I'll line up these two with my straight edge to get my slopes for my segments. And then finally do -2, and the slope is -3. So again, you're going down 3 and right 1 to get your point to line up with. Okay. And then when you get there, well, you don't have anything to line up for those final ones. Okay. Now, when your differential equation depends on x and y, then you have to have a third column in your chart. So you've got to have x, you've got to have y, and then you've got your dy dx. Okay, so this becomes where you do a little bit more. And I'm going to tell you how I've seen this shown on AP is they'll say just do these 9 points, okay? Or just do the slope field for these 6 points. We've seen that happen. I'm going to do for these 9 points that I'm kind of showing here. Okay, so let's start here. That is -1, 1. So that would be a slope of -1 minus 1, which is -2. So at this point here, you would line it up with down 2, right 1, and you've got your little slope. Okay. Then do this point, which is -1, 0. That would be -1 minus 0, which is -1. So from here, you're going down 1, right 1 to line up. There we go. Okay. Then do this one. It's -1, -1. So -1 minus -1 would give you 0. So that's where we're going to get our horizontal line from. And then let's do this one. That's 0, 1. So that would be 0 minus 1. That's -1. So from here, you're going down 1, right 1 to line up your straight edge. Okay, then you've got 0, 0. 0, 0. 0 minus 0 is 0, right? Then you've got 0, -1. That would be 0 minus -1. That's +1. So for this one, you're lining up with up 1 over 1. Okay. And then you've got 3 more. So let's see, that would be 1, 1. That's going to be a slope of 0. So that's horizontal. And then you got 1, 0. So that's going to be a slope of 1. And then you got 1, -1, which is going to be a slope of 2. So there you go. And so that's what happens when your differential equation depends on x and y. You don't necessarily get these vertical consistent patterns. Each point is different. And like I said, a lot of times on AP, they'll say, okay, draw the slope field for these 9 points. So I hope that helps with number one, drawing a slope field. Now, the second skill you need is to be able to take a slope field and sketch a solution. So what you're doing here is you're looking for that, uh, and they tell us here to sketch the solution through the point 1, -1. 1, -1 would be here, okay? But notice it has a horizontal little slope there. That means I've got a max or a min. But look at these slopes here, okay? They are guiding you, right? They're guiding you as you draw. Gets steeper and then flatter, right? And then they're guiding you to have that curve. Now, is your curve going to be perfect? No, it's not. But you're going to have some key points. I mean, you knew there was going to have to be a minimum there looking at the outline of the slope field. So keep that in mind. Now, the third skill is being able to match a slope field to a differential equation. Okay. And so I've got some just graphs here, and I've got some differential equations. We'll just do a few of them. Remember that you are looking for the antiderivative to be graphed here of this. So for instance, if I know the antiderivative of cosine, of sine is negative cosine, I'm looking for the slope field that outlines negative cosine, okay? I know A is not going to be it because I don't get that wave motion, right, of negative cosine. I know B is not going to be it. I know C is not going to be it. You get the idea, right? So really the only ones I'm looking at are D and I. Mhm. Now think about negative cosine. Where does cosine's graph start? Starts on the y-axis, right? We start at a hill. But because it's negative, we're going to start at a valley. Well, does this start at a valley or does this start at a valley? Looks like I starts at a valley. But do you see how I processed through all of those? Look at 3 here. The derivative of dy dx equals e to the x. The antiderivative would also be e to the x. Which of these slope fields is outlining e to the x? That's right. Okay. So I really want you to be thinking, looking for the antiderivative and then looking for the slope field that outlines that for that third skill. But good practice if you can match some graphs to equations. And then finally, match a slope field to the solution. Okay, so on this one, this is where you're actually looking for this graph. Okay, so which of these graphs is outlining y equals x? That has to be C, right? That is y equals x to a T. It's just where are you going to be shifting it up or down from? Okay. And those are really, let's do one more. You've got y equals e to the x. Which one of these is outlining y equals e to the x? Well, that would have to be F, right? It's outlining y equals e to the x. So practice all 4 approaches so that you become more comfortable and you're ready for that. I mean, the fun part is the drawing of the slope field. My least favorite is drawing a particular solution, but I can really get into the matching and by really training my eye to be looking for the right piece. So thanks for watching. I hope this helped with the slope field. If you have questions or comments or you'd like to see videos on other topics, please feel free to let me know down below. I'd love the opportunity to help. Bye for now, everyone.